So, give me one sec. We should be finished with linear motion, or not linear motion, the introduction. So the first thing we need to do in linear motion is clear up some vocabulary. And the first vocabulary word that you guys need to know is distance. What is distance? Space? Distance is distance? How would you guys define what distance is?
How far or close away an item is?
How far or how close? There's actually a better definition that I want you guys to use. Because how far or how close actually refers to another concept called displacement. Distance.
Between two distant objects and then let it go.
Distance is how far you travel.
I have no idea what
Okay? So when we're referring to the distance an object moves, we're referring to how far it travels. Cool?
Cool.
So those of you who are listening, you might want to take that down in your notes. So, okay?
I'll take it down.
The second term, displacement. So displacement is what you guys are talking about. When I'm talking about starting in final position, the object's displacement is that space in between the two. Okay? And more importantly, displacement has a direction. It's carrying how much space is in between, and in what direction do I need to travel to get to my final position. That's what displacement is referring to. The space in between those 2 points and the direction in which you travel to get there. Cool? Yes? The next term, position. Now you guys have probably already seen position in math. Can somebody tell me what position is? It's not displacement.
No, you just said
Placement? As in what? Clarify. Specific area? You can get a better definition. Anyone else?
Like a specific area within an area.
It's a location with respect to another location. So when we talk about the position of an object, we're referring to its location with respect to another. So this object's position is that. Here's where it's referencing to. That's its position. Cool? Does that make sense? So it's referencing itself to something else, and typically it's referencing to the origin. That's position. Now, displacement is also called the change in position. Cool? Yes? The 3 of you that are listening, 4 of you? Okay. So, referring to our base units, what is the base unit for distance, displacement, and position? It's a meter. So all of these are measured in meters, or kilometers, or whatever it is. But their base unit is a meter. Cool? These are also considered vectors and scalars. So vectors are something that has a size, which means the spacing, and a direction. Which way is it moving? Where scalars only has a size, telling me how big it is. So of these 3, which one of them do you think are scalars? Which only carry about the size, but not the direction.
Position.
Position actually isn't. Position's a vector. Which means that it carries about the size and the direction. Cool? Displacement? Displacement turns out to be a vector. It carries about the size and the direction it takes to get to the final position. So distance is the only scalar. So it doesn't have a direction associated. And the interesting thing is distance can only be positive, where position and displacement can be both positive and negative values. Cool? Does that make sense? So far, so good? Not too complicated material? All right, give me 1 second, and then we'll talk about velocity and speed.